Hi, welcome to another revision session for Common Test June 2012 paper. Question 1.6. The sinusoidal voltage Vt is equals to 65 sine 377t plus 10 degrees phase angle is applied to a circuit with an impedance of Z equals to 250 ohms at an angle of 36.9. And what does the question want us to do? To determine the current of the supply IT, in other words the total current flowing into this circuit, and determine the phase relationship between Vt and IT. Right? Okay, to start this question, we need to look at specifically the voltage first. So what we do, we convert the voltage sinusoidal expression into a phasor. So V equals to V RMS angle 10 degrees. So now V RMS is V peak over root 2, so that's equals to 65 over root 2 at an angle of 10 degrees. Right, so that's the phasor version of the supply voltage, and we are given that the impedance Z of the circuit is 250 at an angle of 36.9 degrees ohm. So we need to determine the phasor version of the current. In this case is V over impedance. That's equals to 65 divided by root 2 at an angle of 10 degrees divided by 250 at an angle of 36.9 degree ohms. That gives us 0.26 divided by root 2. Right, I'm going to retain the root 2 because later on we will convert back to sinusoidal waveform, where the angle is 10 degrees minus 36.9 degrees. That gives me 0.26 over root 2 at the angle minus 26.9 degrees ampere. Alright, now to convert this to sinusoidal, I will have IT. Now this time I need V peak. Right now V peak is RMS value multiplied by root 2. Sine omega remains the same, so in this case it's 377t, but this time the angle is a negative, so it's 26.9 degrees ampere. That's equals to 0.26 sine 377t minus 26.9 degrees amps. So that is the sinusoidal expression for the current for this case. Alright, and part 2 is the phase relation. The phase relationship is determined by the angle between these two waveforms. Phase relationship, phase D is phase V minus the phase of I. That's equals to phase is 10 degrees minus 26.9 degrees, which is 36.9 degrees. Now since the voltage is a positive, if I were to draw the phasor diagram, the voltage is a positive 10 degrees and the current is a negative 26.9 degrees. We say that the voltage is leading the current, or current is lagging voltage by how much? By 36.9 degrees. So that's the phase relationship between voltage and current. Well, I hope you have learned something in this video. Thank you. Bye.